So in this video, I want to clear up just a couple of basic topics and then we'll do some applications. So we want to talk briefly about what's referred to as the discount rate. This is the interest rate per year. In the corporate world, we would refer to this discount rate as the cost of capital. It's the cost of financing. So if you were only going to use cash, if you're going to use cash from your checking account, the discount rate reflects an opportunity cost of capital. What could you invest that money in? If you are a sole proprietor, right, your only source of external funding are loans. So the cost of capital for a partnership or a sole proprietorship, right, is the interest on the loan. If you're a corporation, you can issue stocks and you can issue bonds. You can even issue preferred stocks. So the cost of financing for a corporation is the weighted cost of those types of securities. So this discount rate, it's the average cost of financing. This cost includes risk and inflation. They're all involved in this package, if you will. One other thing before we look at some problems is to talk about present value. The other example that we were talking about was future value. We had that project that you spent $40 on. You were going to get $7.50 for 9 years and then $17 the last year. That's a future value question where you're moving forward. That's your timeline. If we want to bring these dollars back to today, though, that's what's referred to as discounting or present value. So this really is the business question. You expect to get cash in the future, but this cash doesn't buy the same thing as the cost of buying the project. So we want to look at the value of these cash flows in total and compare that to the cost of buying that benefit. So let's look at some examples. If you have a spreadsheet, if you could open Excel, you could do it in, it could be in Apple, it could be in Google Drive, or it could be Excel itself. If you look, you know that there are lines on the left side of the spreadsheet, and there's columns across the top. If you create this box, these boxes, if you will, in these cells, right? The yellow boxes are all going to be under column D, and the first piece of data you're going to have, future value, is going to be on line 8. So again, if you enter these boxes in 8 through 18, and everything here in column D, this is obviously column C. The formulas then are here for almost all of the items or all the problems that you might want to ask. So let's go through and talk about this problem. You want to invest $12,000 today. It's expected to earn on average annually about 13% for 7 years. How much will you have at the end of that 7 years? So if we look, we know what? The present value is right here. And again, we need to remember that's negative $12,000. Why is it negative? Because it's an investment. The annual interest rate is 13%. Now you have to watch and make sure that your formatting works. This really should be 13%, or it might be 0.13. Time in years, 7 years. So we know it's 7 years. Now this tells us we're going to do this annually, so this box has to be a 1. If we look over here then, and I'm sorry, this box is going to be a 0. That's the tells us, is this an ordinary annuity, or does it ask, it says, do the cash flows happen at the beginning, at the end? At the end is 0. So now if we're calculating future value, you need to plug that in right here. The answer will be in this box. And here is the formula. You take equals future value, and then you look at these cells over here. It's D10 divided by D13. That's the rate per period. D11 times D13, that's the number of periods in the investment. D16 is the payment. There's no payment, right? It's 0. D9 is the present value, right? That's at negative 12,000. D15, that's this box here, that for all of our examples, it's always going to be a 0. So what does that equal? Again, if you look at the numbers as we calculated, that value will be $28,231. That's $12,000 invested 7 times, gives you that future value. Next. So again, you see what? $12,000, 13% per year, and that happens over 7 years. It grows to $28,231. What I would suggest you do is pause this slide and open your Excel spreadsheet, plug in the numbers, and make sure you get that answer. Now, we talked about changing compounding frequencies. Again, that's this line right here, number 13. If you invest $1,000 today for 10 years and you can earn 10%, how much will you have at the end of 10 years if you compound annually? Now, the second question here is the effective return. And we'll talk about that here in a second. But let's find this answer first. Negative 1,000, 10%, 10 years, compounding frequency 1. What's the answer for that? What's on the next slide? So let's go to the next slide real quick. Again, you can pause right now, solve the problem in Excel or with the formula, whichever you would rather do, and then check the answer. So the answer is, here we are, 1 time a year, it's $25.93 and some pennies. The effective interest rate is 10%. So if it's an annual return, the interest rate per year equals the effective rate, which is also 10% in this case. What would happen, though, if you did it quarterly? To solve this problem quarterly, again, if you're not using formulas, if you're using Excel, all you have to do is change this box to a 4. That will then calculate the interest rate per period. There's 4 periods in a month or in a year. So 10 divided by 4 is 2.5%. And then it also would calculate the total number of periods. 4 per year for 10 years, that's 40 periods. Now it's going to calculate the end value. If we look for the end value, here it's 4. It's $26.85. Once a year is $25.93. 4 times is $26.85. So it's the same investment, but it grew to a greater value. So what does that mean? that means it must have earned a higher rate of return. So the effective interest rate is the actual interest rate that you earn for the period. If you did it for 365 days, 2717, again, you earned even more. The effective interest rate is 10.52. So the effective interest rate is very important if you want to compare cash flows that have different compounding structure. For instance, a bond calculates interest twice a year. Stocks calculate 4 times a year. If you invest in mutual funds, many mutual funds pay interest monthly. So if you want to make comparisons between those 3 types of securities and returns, you need to be able to annualize them so they're on an equal playing field. To find present value. When you're 5 years old, grandfather tells you that when you graduate from college at 22, he'll give you $50,000. If inflation is 3%, what is that worth in today's money? The second part of the question this is, if you took that money, right, if you had that value today and your parents invested for you at 8%, how much would you have at the end? So again, we have to remember, what do we know? In this case, this $50,000 is a future value. The first part of the problem, the return, is inflation, which is 3%. In the second question, it is 8%. And again, since it doesn't tell us anything specifically about compounding periods, you have to assume that it's always annual. So here's our example. Here's the first one. $50,000 a future. What's that worth in today's money if inflation's 3%? That's worth roughly $34,047 and some pennies. Now, when you're doing homework problems, things like that, you have to be aware of what the problem asks you for. If it asks you to round to the nearest dollar, that means you have to get rid of these decimal points. You can do that in Excel, right? There's a way to get rid of decimal points. You need to explore how to do that. But if it asks you for pennies, in this case, it is actually rounding it to this penny. The other example says if your parents had that money and invested it today at 8%, what would you have in 13 years? Now the answer is $92,595. Again, these are just lots of questions and examples of the way we can ask some of these questions. What about future value and payments? Your company wants to buy a piece of equipment that'll cost $500,000 in 12 years. If you want to make annual payments to save for this, how much would you pay starting at the end of this period? So at the end of the year, if you need $500,000, how are you going to do that, right? If you can earn a certain interest rate. So again, I'm going to plug in these yellow numbers. The formula is over here. You want the future value of an ordinary annuity, and that's this formula right here. Notice at the end, it has a 0. So let's see how that works. Again, $500,000, that's what you need in the future. Here's your interest rate, time in years, once per year. You're going to have to make an investment of $19,493 every year for 12 years. That'll give you $500,000. What if you did it monthly? In this example, all you have to do is change the compounding frequency from once per year to 12 times per year. Every month, you would need to invest $1,456 to get $500,000. What about, again, another kind of an annuity problem? Let's assume you win the lotto. The jackpot was 20 million. The state has offered you $1 million a year for 20 years. We'll ignore taxes. Or a lump sum. How you find the lump sum is it's the present value of the payments. So how much must the state invest today? That is, what is the lump sum to pay out the annuity if they can invest at 6%? So again, we're going to solve now for what? The present value of an annuity. So let's look at this problem. The payment, you're going to get $1 million. You're going to receive it, so it's positive. If they can invest at 6% for 20 years, they need to invest $11,469,000 odd dollars to give you $1 million a year for 20 years. So for you to get 20 million over 20 years, they need to invest 11,000. Now, what if you took this amount? Because this is like the lump sum. If you took the lump sum and you could invest it at 12%, how much could you withdraw per year? So that now is asking us to solve for a payment. The present value, you'd invest the 11,469, right? You're going to earn 12%, 20 years, once per year. So the payment that you would receive, you would be able to withdraw 1.5 million. So would you rather get 1.5 million or would you rather get $1 million? Hopefully you know the answer to that question. So again, here are some examples. What I would like you to do is pause and see if you can do this math, right? The annuity questions are much more complicated, right? So Excel is much easier. It's the same formulas that we used before, except now there'll be a value for payment. So in this case, what's the present value of $1,000 invested at the end of each 20 years if the discount rate is 12%? You want to know the present value. Plug that in here and you'll see what that value is. When you solve this, in the end, it's around $7,469. Again, solve that, pause this real quick, see if you can get that answer. Also, what I would suggest is go to Excel, see if you can plug the numbers in, and again, get that same answer. Your textbooks talk about something called equivalence. And essentially all they're saying is that there's two cash flow streams that have the same present value. If two things have the same value, you can transform them any way you want and you will get the same answers. Now, how I look at this, I think it's confusing myself. Think about a loan, because that's really kind of the example that they're telling us, right? You have a contract that pays $2 million per year for 4 years, and it has a present value of $5.7 million, discount rate 15%. So the question here is, look, 5.7 million, that's the cost. You're going to withdraw $2 million a year, but you're also going to make money on the investment. So you invest $5.7 million, it earns $856,000. So the end of period principal then is 5.7 plus 856,000 minus 2,000. So that now gives you a period at a balance at the end of $4,566 million. What do you do with that? It earns 15%. Add those two things together, 5.27 or 5.25, subtract out the 2 million, gives you 3.2. This is really kind of an example of a loan. So let's think about how this would work if it was a loan. There is an example, a worksheet that I provide people that does what we refer to as loan analysis. But really, you just need 4 boxes. You need the loan amount, the maturity in years, payments per year, and the annual interest rate. So your payment per period, here's the formula. So it's the payment. Then you have to add, if there's anything in this box down here, D16, any extra payment that you might like to add. In this case, it's 0. So you come up with, now it's a little rounding error, but you're roughly $2 million. And if you plug that, look at what we refer to as the amortization table, it's just that other table that we looked at. 5.71 million. 856,000 is the interest. So 5.7, 2 million minus that means we reduce the principal by 1.143. We have 4.56 left. You make a payment of $2 million. Interest on that, 684, leaves you with 1,315,000. Subtract these. In the end, what? At the end of 4 years, you have $0 left. So here's a quick example, just to say, you have a $6,000 loan at 10%. You're going to make payments for 4 years. You want to find the size of the payment. And we want to create an amortization schedule. So you put the numbers into the cells, right? And you should get a value of $1,892. So if you create this table, times 0 through time 4, add the payments, start the balance at $6,000. What is the interest payment the first year? It's the balance, 6,000, times the interest. 6,000 times 10%, $600. So you paid $1,892. Interest was $600, so that means you reduced the principal by $1,292. That leaves $4,707 on the loan. You pay interest on that the next year. 10% of that, $470.72, subtracted from $1,892, means you reduce the loan by $1,422. If you do that properly, in the end, at the end of the 4th year, you will have $0 in loan, right? You paid off the loan. So again, some of those might be a little complicated, but again, if you pause the video, try to do the math, right? You can either do it with Excel. You might be able to do it if you in the class, you might be able to use the Excel worksheet that I provide, or you can just use the formulas. And I'll tell you, the formulas, especially for the annuities, is much more difficult. So that's the end of this video. I look forward to seeing you again.